Going over to question 6 now. In this question, we have a right triangle, and from the beginning, we know that R and S are not the right angle. Neither of these are the right angle. And that's because we're hearing about sine of R and cos of X. And in right triangle trig, you're not going to hear about the sine, cosine, or tan of a right angle. It's one of the other angles that you'll hear that kind of thing about. Next, we're hearing that we have the sine of R and the cosine of X. Well, by the way, let's put the right angle here, and we know that that's t. But sine of R and cosine of X in a situation where R and S are complementary, that's a reference to something. Now, why do we know R and S are complementary? Well, because the three angles of this triangle have to add to 180. So if t is 90, that only leaves 90 degrees left in the triangle. So the other two angles have to add up to 90 as well. So all of this is a reference to the idea that the cofunctions of complementary angles create equal expressions. If two angles add up to 90, then the sine of one of them will equal the cosine of the other. So if a plus b equals 90, then the sine of a equals the cosine of b. And the sine of b equals the cosine of a. The order doesn't really matter, but the sine of one of them equals the cosine of the other. Now, of course, you could set up statements. Sine is opposite over hypotenuse. Opposite is 15. Hypotenuse is 4. But that would be missing the reference and the shortcut in this question. If R and S add up to 90, and they do, then, as we said a moment ago, the sine of one of these angles equals the cosine of the other angle. And the sine of R, we were told in the question itself that that equals root 15 over 4. So what does the cosine of S equal? It equals root 15 over 4.